All right, so let's go on to the next question. So let me move it over to my iPad. Cool. All right, once I move it over to my iPad, it should show it on my iPad, Melinda. Cool. So yeah, you could just write it like this. So you could say x is greater than or equal to 7. Because you don't have to really put the 10 because pretty much we already know the cutoff is 10. So you could put it right here. But like if I did give you this question on like a test or on a quiz, it most likely would be like a multiple choice question. So you don't really have to worry about how to write it. So, or you just have to worry about getting me the probability, not how to write it. All right. Sweet. All right. So let's go on to page number 9. So for page number 9 is how to find the mean and how to find standard deviation when we have a binomial distribution. So if you look at the formula, when we have a binomial distribution, in order to find the mean, which is this top one right here, or the mu, you get your n and you multiply by probability of success. If I want to find standard deviation, you take the square root of n times p times q, and that would give you standard deviation. So if I ever ask you to find the mean or the standard deviation, this is all you have to do. You have to do n times p or do square root of n times p times q, and that will give you the mean or the standard deviation. Any question in regard to the formula before we actually get to the problem? Cool. All right. So let's go on to this problem. So for this problem, it says a quiz for a psychology class consists of 10 questions. The questions are multiple choice for 4 possible answers each. A student randomly guesses on 10 questions. Find the mean and write a sentence describing what does it represent. All right, so let's find the mean. So the mean, for this one, we already said n is equal to 10. And we already said, oh, well, for this one, are probably going to change. So for this one, how many total possible answers are there for a multiple choice?
4.
Yeah, 4. And then they tell us, like, if you think about this, it should be 1 out of 4 because there should be 1 correct answer out of the 4 possible correct answer. So that's our n, that's our p. So let's find our mu. So our mu will be 10 multiply by 1 out of 4. If you do that math, it should give you 2.5. Everybody got on the 2.5 for the mean? So we're gonna go, what does it represent? So the represent is, it's telling you on average, how many questions should we expect you to get correct? So it's telling us on average, we should expect this person to get 2.5 questions correct. But we kind of know we can't get half of a question correct on a multiple choice question because either you got it correct or you got it incorrect. So the way we could just write it, we could just say, ooh, too big. So say we should expect a person so we should expect a person who is guessing to get 2 to 3 problem. Correct. All right. So that's what the mean represents. It just represents how many questions should we expect a person to get correct. So we should expect them to get 2 to 3 correct problem if they're just guessing. All right. So do you always think they're always gonna get 2 to 3 questions correct, or is it possible that they could get more than 3 questions correct? So it should be possible for them to get more than 3 questions correct or less than 2 questions correct, because that's what the standard deviation is gonna tell us. The standard deviation gonna just tell us like how much above or how much below the average is possible. So right now we're gonna go ahead and we're gonna go ahead and find the standard deviation. So for the standard deviation, we're gonna get square root of n, which is 10, times 1 out of 4. And this is Q. So Q is always 1 minus P. So 1 minus 1 over 4, which is just 3 over 4. So you put 3 over 4 over here. And let's see, what do we get? So it's a square root of 10 times 0.25. You get 1.369. So for our standard deviation, we get 1.369. So that is telling us how like far away from the mean we could possibly be. So you're telling us, yeah, like for most of the cases, we should get 2.5 question correct, but the standard deviation telling us that we could either go kind of one question correct above that or one question correct below it. So kind of telling us we should expect anywhere from maybe like 1 all the way to 4 question correct. But if I'm just guessing, if I get like 10 question correct out of 10, there's something wrong, because that's very unlikely for somebody to get 10 question out of 10 question correct, given that they're just guessing on all 10 questions. All right, but that's it for B. Any question for B? All right, so let's move on down. All right, so we'll do this last one, then we're gonna move on to the Poisson distribution. So for this one, says Stephen Curry make 42% of his 3-point attempt. If Stephen Curry shoot 10 3-pointer in a game, what is the probability he make exactly 6 of the 10 shots? All right, so right now we're gonna go ahead and we're gonna go ahead and get N, we're gonna get P, and we're also gonna go ahead and get X. So for this one, what should be my N? How many 3-pointer is Stephen Curry gonna shoot?
10.
Cool. What's the probability that he make a singular 3-point shot?
42.
So 42. And for this problem, how many shots do we want him to make?
2.
So how many?
6. 6.
Yeah, we want him to make 6, because we said 6 of the 10 shots. Cool. For this one, would this be a CDF problem, or would this be a PDF problem?
PDF.
PDF. The reason why we know it's PDF, because we have a singular X value. All right, so let me transition over to class calc, and let me get the answer for this one. All right, so let me erase this. Cool. All right, so we're gonna go over where it says stats. We're gonna go distribution. We're gonna go binomial distribution. N is equal to 10. P is equal to 0.42. we said this should be a PDF, and we said the PDF for this one, x is equal to 6. So for this one, we'll say probability that x is equal to 6 is equal to 0.130. Oh, wait, say 4. All right, and that's it for A. Any question in regard to A? All right, let's do B. So for B, it said at least 6 of the 10 shots. So for this one, what should be my X?
One, no, 6, 7, 8, 9, 10.
Cool, 6, 7, 8, 9, and 10. Perfect. So yeah, X should be all of those because it says at least 6 of the 10 shots. So that means he can make 6 of the 10, 7 of the 10, 8 of the 10, 9 of the 10, and 10 out of the 10. Cool.
And you're
So-
using CDF.
Perfect. So for this one, you do want to use CDF because if you look at it, you want a range. So let's go over to class calc and let's go ahead and do that. Any question why we're using CDF versus PDF? So we'll say CDF. So if we're doing CDF, the lowest should be 6 and the highest should be 10. And if you look at the drawing right here, you can see it shows 6, 7, 8, 9, and 10. So if you look at the probability for that, that give you 0.202. And that's your final answer for that last problem. All right. Any question in regard to B? All right, so let's do C. So for C, it says how many three-pointers should we expect Steph Curry to make? So for this one, are we finding a probability?
Yes.
Well, if you look at part C, does it say anywhere to find a probability?
No.
No, if you look right here, there's actually a keyword that tells us what to find. What do you think the keyword is? Cool, thank you, Elizabeth. So it should be expect right here. Because expect is telling me to find the mean. So what we want to do, we want to find the mean because it's asking us like how many shots do we expect them to make. So for this one, how can I find the mean for this one? Well, if you remember the formula, it said you get n, you multiply it by p, so you get 10, multiply that by 0.42, and we get 4.2. So that means if Stephen Curry shoot 10 three-pointer, we should expect him to make, we should expect him to make 4 of the 10. So there are going to be nights where he make like 5 out of the 10, or there might be nights where he make 3 out of the 10. But the meaning is telling us this is how much we should expect him to make if he does shoot 10 of them. All right, and that's it for that last problem. Any question in regards to the last problem? Cool. All right, and if you need like an extra one, you could just do this other question, and that should help you out for binomial. Cool. All right, so up next we're going to 5.3. So for 5.3, it's going to be the Poisson distribution.